to
Dr. Ismail Petrus, MA.
3, 2, 1.
Hola, hello everyone. I am Tridevi Wulandari and my last student number is 004.
Hello, my name is Nikki and my last student number is 005.
Hello, I'm Rosa Febrinrawani and my last student number is 003.
I am Meridiana Haidunisa with the student number 008.
Hello, I'm Alisari Putri and my last student number is 006.
Alright, we are from Group 2. We are going to talk about descriptive statistics, measures of dispersion. Measures of dispersion help us understand how spread out the data is. They include range, variance, and standard deviation. First, let me explain about range. Range is the simplest measure of dispersion and is calculated by finding the difference between the highest value and the lowest value in the data set. The range is a quick and dirty way to get a feel for the spread of the data set. However, the limitation is that it only relies on two data points to describe the variation in the sample. The range does not include any values between the highest and the lowest points. Let me provide to you the formula of range. Now, let's take a look to the example. For example, there is a question like this. Please determine the range of the data. Here is the data. 7, 9, 8, 11, 4, and 5. Based on the formula, we have to find the highest value. After that, minus, dikurang, the lowest value. Okay, now find the highest value from this data. The highest value is 11. And then the lowest value is 4. Yang terbesar adalah 11 dan yang paling terkecil dari data ini adalah 4. So, we have to follow the formula. The highest value is 11 minus the lowest value. The lowest value is 4. 11 minus 4 equals 7. So, the range would be 7. Now, it's your turn to find the range of this data. Okay, let's check it out. There are 2, 3, 6, 8, and 11. Okay, remember the formula, the highest value minus the lowest value. Where is the highest value? The highest value is 11, and then the lowest value is 2. Okay, the highest value minus the lowest value equals 9. So, the range of this data is 9. We got it. The range is 9. The second part is variance. What is variance? Variance is a measure of dispersion that describes the relative distance between the data points in the set and the mean of the data set. It summarizes the squared deviation of each data value from the mean. Let me provide to you the formula. As you can see here, and I will explain each symbol from this formula. The first is this symbol. It is called variance, sample variance. The second is this symbol called sum of, or we can call it sigma, or it is in Indonesia jumlahnya. Next, the third is this symbol, sample mean, or average of all data points, or in Indonesia, nilai rata-rata. And the fourth, this symbol, each individual data value. Next, the fifth, this symbol, like letter N here, it is number of data values in the sample. Or in Indonesia, banyaknya data. And the last is this symbol, deviation of each data value from the mean. Now, let's take a look to the variance example. For example, in a class, there are 10 students with heights in centimeter as follows. You can read by yourself. Okay. The question is, determine the variance of the data above. There are 3 steps or 3 ways that we can get the result. Okay. The first is calculate the mean of the data values. The mean is the total sum of all the data values divided by the number of data points. Okay. Here you can see on our book, page 9, okay, there is a formula how to find the mean. Okay. X bar, okay, equals, like I told you, this is sigma. Sigma is like amount of the data. And then divide it into
by
the number of the data. Here, the formula is n. Okay. So, this is the amount of the data. Okay. Because we take it from the questions. This is the amount of the data. And then, we follow the formula.
is divided by
into
10.
Where we get the 10? We get the 10 from the number of the data. The number of the data, there are 10. Why? This one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
That's why we divided by 10.
Okay? So, the amount of the data
Is divided by
into
10.
How much? Okay. The amount of the data
Is divided by
into
10
is 1,590. Okay, after that, we divide
by
into
10.
1,590
Is divided by
into
10.
The result is 159. So this is the mean. The second step is calculate the deviation of each data point from the mean. This is done by subtracting the mean from each data value. You can see from the formula here, sigma x minus x bar squared. Okay. These numbers we got from the data above. Okay, and so on. Okay. The numbers from the data above minus 159. Okay, where we get this 159? We get this from the mean that we got before. This is the result of the mean. After that, it is squared, right? This is the squared. We follow the formula. After that, the numbers, okay, just follow the rules.
After being added,
this is the result. This is the result from the number 1, the second, the third, okay? We got it. And then this is the result after being added. 1,258. Finally, we are going to have the result of the variance. This is the formula of variance. And this is the variance itself. Sigma x minus x bar squared divided by n minus 1. Remember, n is the total or the amount of the data. Remember that there are 10. Okay? Okay. So from the formula above, before we got the result 1,258. Okay? And then we follow the formula. And here, how much the total is? The total is 10 actually, right? There is 10. The total is 10. Because the formula minus 1, so we have to 10 minus 1 is 9. So that's why 1,258 divided by 9 equals, okay, let's prove this. divided by, we call it the variance. Okay, we got the variance here.
Hello, my name is Nikki and my student number is 005. After telling you the range and variance, next is about standard deviation. Standard deviation is simply the square root of the variance. To calculate the standard deviation, you must first calculate the variance and take the square root of the result. The standard deviation is actually a more useful measure than the variance because the standard deviation is the units of the original dataset. As you can see on the screen, that is the formula to calculate the standard deviation. Whereas is standard deviation x minus x bar, the deviation from the mean for each value in the dataset. N is the size of the sample or the number of data values. Then, after Devi and I told you how to calculate range, variance, and standard deviation manually, now I will be delivering how to calculate them by using Microsoft Excel. First is range. You need to click this cell and click equal on your keyboard. Type max and highlight the column, then click minus on your keyboard and type min and highlight the dataset and click enter. Next is variance. First you need to click this cell and then click equal on your keyboard, type VAR and highlight the column and click enter. Last is standard deviation. Click equal and type on your keyboard is STDEV. Alright. Then highlight the column, the dataset. Then click the enter. Alright, I think it would be all about the standard deviation to calculate manually and how to operate Microsoft Excel to calculate the range, variance, and standard deviation. I think it would be all. Thank you.
Alright, after learn how to use Excel to calculate dispersion, now we will continue to explore how to use SPSS to calculate central tendency and dispersion. To calculate central tendency and dispersion, there are two methods can be used. The first one, by click Analyze and Descriptive Statistic and select Descriptives. And the second one, by click Analyze, then Descriptive Statistic and select Explore. Now, let's look at the example. Calculate the variance, standard deviation, and range for the following dataset, which are 20, 15, 24, 10, 8, 19, and 24. The first step is to click the Analyze menu on the toolbar, then select Descriptive Statistic, next choose Descriptives, and finally click OK. Here is the result. You can see that the output include N, which is number of the data, range, minimum value, maximum value, sum, mean, standard deviation, and variance. Now, let's use the second method to calculate central tendency and dispersion. The first step is same as the before. By click Analyze, then Descriptive Statistic, then select Explore, and finally click OK. Here is the result. So, that was how to use SPSS to calculate central tendencies such as mean and median, and dispersion such as range, variance, and standard deviation. Now, let's continue to the next topic, which is mean deviation. Mean deviation is a way to measure how much the numbers in a group are spread out from the middle value or the average. It is calculated by using the three steps. The first one, find the mean of all values. The second one, find the distance of each value from the mean. And the third one, find the mean of this distance. For example, calculate the mean deviation for the data 3, 6, 6, 7, 8, 11, 15, and 16. To calculate that, the first step is to find the mean using the method learned last week, which is by summing all the values and dividing by the number of values. Then we get 72 divided by 8, which equals 9. The second step is to find the distance of each value from the mean by subtracting the mean, which is 9, from each value. Like 9 minus 3 equals 6, 9 minus 6 equals 3, 9 minus 6 equals 3, 9 minus 7 equals 2, and so on. It will look like this, where 9 is the mean, 3 is the value, and 6 is the distance. This pattern continues for all values. The final step is to find the mean of those distances using the formula. Mean deviation is equal to the summation of the absolute value of x minus mu divided by n. So, the mean deviation is calculated as 6 plus 3 plus 3 plus 2 plus 1 plus 2 plus 6 plus 7 divided by 8 equal 30 divided by 8 equal 3.75.
Alright, as my friend explained about mean deviation, now we will learn about absolute deviation. It refers to how far something is from a specific value such as the average, without considering whether the difference is negative or positive. So we will use the absolute value bars to ensure all values are treated as positive. It helps us to understand how consistent or spread out values are in a dataset. Now let's see how to calculate absolute deviation. For example, there are 5 students who took a test and their scores are 70, 90, 85, 65, and 60. First, we need to find the average. Add all the scores together and the result is 370. After that, we need to divide the total sum by the number of scores, which is 5. So the average is 74. Next, calculate the absolute deviation by subtracting each score from the average. As you guys can see here, some values will be negative. But since we want all values to be positive, we apply the absolute value bars to convert them into positive values. Finally, we need to find the mean absolute deviation, or MAD. We calculate the average of the absolute deviation values, which gives us 10.8. To confirm the calculation, you can split the absolute deviations into 2 groups. One for the negative values and the other one is for positive values. Both sides should be equal. If they are not, there might be a mistake in calculation. Now let's try it in Excel. Input each student's score in one column and then use the average formula to find the mean. After that, we can use the column next to it for the absolute deviation. Use the formula equals ADS, open brackets, input the average, which is 74. After that, click on the score. If we already entered the formula, we can copy it to the remaining rows. And that's it. To find the MAD, we just need to find the average of absolute deviation values. Now let's move on to coefficient of variation. This is useful when comparing results from 2 different surveys or tests with different measures or values. To calculate the CV, we need to divide the standard deviation by the mean and multiply the result by 100 to express it as a percentage. For example, let's say we have 2 datasets. First, we need to find the mean for each sample by typing equals average, click and drag, select the data, and then press enter. After that, we can find the standard deviation for each sample by typing the equals stdev, open bracket, select the data, and press enter. Now, how to calculate the coefficient of variation? We can input the formula by typing equals, open brackets, click on the standard deviation, and divide by the mean. After that, we close the bracket and multiply it by 100. And so that's how you calculate the coefficient of variation.
What is the IQV? The index of qualitative variations, or IQV, is a way to measure how diverse or varied a data set is for nominal variables like race, ethnicity, or categories. Scale IQV ranges from 0 to 1. If IQV equals 0, all cases belong to the same category, no diversity. If IQV equals 1, cases are evenly spread across all categories, maximum diversity. The IQV formula compares 1. Actual differences in the dataset. 2. Maximum possible differences if the categories were perfectly even. How to calculate IQV? 1. Count the number of categories K. 2. Find the total number of cases N. 3. Calculate the percentage of each category, square them, and add them up. Sigma PCT squared. 4. Use the formula IQV equal K 100 squared minus sigma PCT squared per 100 squared K minus 1. How to choose a measure of variations? The choice depends on the type of variable you have. 1. Nominal variables categories. Use IQV to measure how spread out the categories are. 2. Ordinal variables rank categories. Use IQV if you only want a rough measure of variability. Alternatively, use the interquartile range, or IQR, to measure the spread between ranks. 3. Interval ratio variables numbers. If the distribution is symmetrical, use the variance or standard deviations. If the distribution is skewed, use the range or IQR.
Don't you hold me like I want